All right, hello DSA 6th grade. This is Mr. Wu, and I'm here to go over your Interim 2 open response questions. So there's three things that I'm always going to be looking for when I read a word problem. The first problem, number 12, is not a word problem, so I'm going to go through it quickly. So this is number 12 on your Interim. So number 12 asks us to divide 4/5 divided by 8/15. So I know that there's multiple strategies to do this, but the easiest way is through using KCF. So KCF stands for, once again, keep, change, and flip. So keep, change, and flip. So we're going to keep our 4/5 the same. Change our division to multiplication, and then flip our second fraction. So instead of 8 on top on the numerator, I'm going to erase that, and I'm going to replace it with the 15, so it's flipped upside down. Then all you have to do is multiply the denominator and numerator. So we have 4 times 15 on the numerator over 5 times 8. 4 times 15 is 60, while 5 times 8 is 40. So I'm going to make a new page. Remember, we have 60/40ths. Our answer here is not done because we can always simplify. So if you see, our numerator is 60 while our denominator is 40. So we can always turn this, that means that this is an improper fraction, and we can turn it into a mixed number. So 40/40ths makes one whole. So I'm going to subtract 40/40ths away from 60/40ths to get 20/40ths left over. And then our 60/40ths, or sorry, our 40/40ths just turns into one whole, right? 40/40ths is one whole. So as a mixed number, this is 1 and 20/40ths. And then we can simplify the fraction here. So we can divide both the top and by both the numerator and denominator by the same number. So here, 20 goes into both 40 and 20. So we'll divide both by 20 to get 1/2. So 20 is half of 40. So our final answer is 1 and 1/2. All right, moving on to question 13. This is where the open response questions get a little bit more complicated. So we have a word problem. So if you take a look at this question, it says students are needed to hand out water and bananas to runners for a 7.5-mile race. So immediately we know that our problem is about a race, and it's about handing out bananas and water. So far our important information is that it's a 7.5-mile race. So I'm going to write that down. Let's continue reading the question. So we have water tables are set up at the end of each 1.25 mile section. Students handing out water will work in groups of 6. So we have two numbers here. We have 1.25 miles and groups of 6. So I'm just going to write that information down. So water tables, so I'm going to write W for water, tables every 1.25 miles. And students work the tables in groups of 6. Continue on. Banana tables are set up at the end of each 1.5-mile section. Students handing out bananas will work in groups of 3. So again, we have two numbers, so those are most likely our important information. So bananas, B, tables set up every 1.5 mile section, and that students are working in groups of 3 this time. So our final bullet point is there are exactly enough students to work at all the tables. So what does that mean? that means that there aren't going to be any extra students who aren't at either a water or banana table. So no students besides at the tables. All right, now we're going to move on to A. A says, how many water tables will be needed? So let's go back to our previous page and look at this. We see that it's a 7.5 mile race, and water tables are set up every 1 1/4 mile. So these are our two important pieces of information here, so I'm going to write them again on our page with A. So 7.5 mile race, and water tables are set up every 1 1/4 miles. So whenever you have a question like this, you might be confused what to do with our numbers. So my recommendation is always to start with a picture. So I'm going to draw a picture. Here's a starting line, right? We're going to draw a racetrack, and here's our end line. We know that this is at 7.5 miles. And now our question is, how many water tables are going to be on the track? So I'm going to pretend that this is actually a number line. So we start out at 0. We haven't gone down the track at all, right? So where is our first table going to be? It's at every 1 1/4 miles. So I'm going to put a mark here, and this is at 1 1/4 miles. Where's our second one going to be? So it's going to be another 1 1/4 miles between them. So I'm just going to add 1 1/4 to 1 1/4. So a quarter plus a quarter is 2 quarters, and then 1 plus 1 is 2. So it's going to be 2 at 2 quarters, or if you simplify that, it ends up being at 2 1/2. But I'm going to keep it at 2 2 quarters just to make this a little bit clearer, and we can simplify it at the end. Our third table, we're going to add another 1 1/4, so we're going to have 3 total quarters, and now 3 miles. Next table is going to be at, oh, it's a little harder now, right? Because we have to add 1 quarter to 3 quarters, which makes 1 whole, because this makes 4 quarters. So we have 1 whole, and then we're adding another whole from our 1 1/4 to the 3, so we have a total of 5. On our next mark, we're going to add another whole to make 6, and then another quarter to have 6 and 1 quarter. What's 1 1/4 past 6 1/4? Well, it's just 7.5. So we have a water table here, water table here, water table here, water table here, table here, and finally a table at the end. So how many tables do we have? We have 1, 2, 3, 4, 5, 6. So this is our picture that helps us see what we're actually doing for a problem. But we could have actually done this in a lot less work. So I'm going to show you how to do that now. If we look at our racetrack, we have a total amount. So a total 7.5 miles. And then we're splitting it up into groups or chunks of 1 1/4 mile. Well, what's another word in math language for splitting something up into chunks? Division. So what we could have actually done instead of doing this whole number line business is just done division. So our total is 7.5 miles that's being split up into chunks of 1 1/4 mile. So we're dividing our 7.5 miles into chunks of, sorry, let me erase that, into chunks of 1 1/4 miles. Now, this is hard to divide. This is hard to do our KCF because we have mixed numbers. So we always want to turn these into improper fractions. So 7 wholes, we want to turn into something in halves so that we have the same denominator. So we're going to turn 7 wholes into halves. So we have 7 wholes, and we want to turn to something over 2, some amount of halves, right? So you can see our denominator just needs to be multiplied by 2 using our equivalent fractions, which means we have our numerator times 2 as well. 7 times 2 is just 14. So 7 wholes is 14 halves. Then we have 1 extra half, so we add that one at the end to get 15 halves. Okay, so now we have 15 halves divided by what? This needs to be turned into an improper fraction as well. So 1 whole, we want to turn into some amount of quarters. So 1 whole is the same thing as 4 quarters, right? So we add that 1 quarter at the end to get 5 quarters. So now our problem is 15 halves divided by 5 quarters. This is a lot easier to deal with, so we can just KCF it. Keep, change, flip. So we're going to keep our 15 halves, change our division to multiplication, and flip our second fraction to 4/5 instead of 5/4. So now we have 15 times 4 over 2 times 5, which is equal to 60 over 10. Now, 60 over 10, remember, fractions are the same thing as telling you to divide. So if you see a fraction bar, you can always turn that into division. So what's 60 divided by 10? Well, that's 6 tables. If we go back to our diagram, we saw that there were 6 tables there. So clearly, dividing gave us the same answer, but instead of drawing a picture, we can just use numbers. So here the picture might have actually been easier, but if you're not too good with your fraction addition, sometimes multiplication is easier because you're just doing multiplication on the top and bottom. You don't have to deal with those wholes and halves. So this is part A of 13, and I'm going to move on to part B. Part B is how many students will work at banana tables. So here we're having students hand out bananas, so I'm just going to, for fun, just draw out a little banana. Oh, that's not yellow. Change to yellow. Oops. Undo those, and here's our banana, right? So this time we're working with bananas. So if we're going to go back to our important information, we can see banana tables are every 1.5 miles, and students are in groups of 3. So groups of 3 and 1.5 miles. Going back to our new page, we still know that we have 7.5 miles of race, and that there's banana tables every 1.5 miles. Banana tables, and students work in groups of 3. So our question is, how many students will work at the banana tables? My first question here is, do we know how many banana tables there are? We don't. We only know that they're every 1.5 miles and that the race is 7.5 miles. We know that at each table, there's going to be 3 students. So we're going to take however many tables we have and have 3 students for each table. But we first have to figure out how many tables there are. Well, if we look at our last problem, we were just figuring out how many water tables there are, right? And there were 6, and we divided 7.5 by 1.25 to get 6. This is the same problem, except for now we're working on bananas. So we're going to make a new page here and do the same problem, but we're just going to skip to division. So we're not going to use our number line because we already know that we can divide our total amount of miles up into the chunks that each banana table is at. So we're starting with 7.5 miles of racetrack, and it's being divided into pieces of 1.5 miles. Same thing we did before. We can do 7 turns into 14 halves. Add the 1 to give us 15 halves. And now 1.5, 1 whole is how many halves? 2 halves is 1 whole. Add the 1/2 to get 3 halves. So now our problem is 15 halves divided by 3 halves. Well, now we can KCF again. So we have 15 halves times 2/3. So this is a trick that you can try, and I don't think we've taught all of you, but I just want to introduce. Do we see how we have a 2 across from each other here and here? This is a concept we're going to call cross-canceling, and you're going to use it a lot going forward in math. So the basic idea is that 15 times 2 is our numerator, right? And 2 times 3 is our denominator. What I'm going to do is tell you that we can flip around our numerator. So 15 times 2 is the same thing as 2 times 15, right? 15 times 2 is 30. 2 times 15 is 30. The order doesn't matter, right? Well, now I'm going to break apart my fraction again. Now I have 2 halves times 15 thirds. Well, 2 halves is just 1 whole, so this is the same thing as just 1 whole, right, times 15 thirds. 1 times anything goes away, so now we just have 15 thirds. 15 thirds is the same thing as 15 divided by 3 equals 5. So what you can do whenever you see two numbers across from each other like this is just cancel them out. And now we have 15 thirds. So this is just a little shortcut you can use. If you didn't understand what I was doing there, then I'm going to make a new page and do it out by hand. So remember, our problem is 15 halves times 2 thirds. So 15 times 2 is 30. 2 times 3 is 6. What's 30 divided by 6? Well, that's just 5. See, we got the same answer, but we just got it in less work here because we can just cancel all the 2's. 15 divided by 3 is 5. Again, don't worry if you didn't understand what's going on there. If you're still confused, just do this method here. So just do the multiplication, simplify. So there's 5 tables, but is that what our question's asking us? No, it's not. Our question is asking us how many students are working at banana tables. Well, now we have to go back to our important information. We know that students are working in groups of 3. So at each table, you're going to have 3 people, right? 1 person, 2 people, and a third. 3 people at each table. And now we know that there's 5 tables. So 3 people at each table for 5 tables is just going to be 5 times 3 equals a total of 15 students at banana tables. All right, part C, we're almost done. Part C asks, what fraction of the group of students will work at the water tables? So what fraction of the group, so of all students, works at water table? Water tables. Show your work, explain how you know. So do we know how many students are working at water tables? We know that there's 6 water tables, right? We've got a total answer of 6 water tables, WT, water tables. So there's 6 water tables, so I'm going to write that down over here. But we don't know how many people are there. We do, however, know that there's 15 students at banana tables. So what we have to do is figure out how many students are working on water tables. Well, if we go back to our important information at the very beginning, we can see that there are students working at water table in groups of 6. So if we have 6 water tables, and students are working in groups of 6, that's just going to give us 6 tables times 6 students equals 36 students at water tables. So we have 36 students at water tables and 15 students at banana tables. So to write this as a fraction, we're going to take our 15 students, oh, sorry, wrong color. 15, whatever. So 36 at water tables and 15 at banana tables. And we just need to write these as a fraction. So our fraction is supposed to be what fraction of the group of students is working at water tables. So we have to know how many students are there total. So we're just going to add them up. 5 plus 6 gives 11, carry the 1. 3 plus 1 is 4, add the 1. We have 51 total students. So our fraction of students that are working at water tables is 36 out of 51 total. We're not quite done though, because this can be simplified. So what I'm going to do is simplify 36 51sts by dividing the same thing on the numerator and denominator. I know that 3 goes into 36 and 51. So 36 is divided by 3 is 12. 51 divided by 3, so 30 divided by 3 is 10. And then I have 21 left over. So a third of 21 divided by 3 would be 7. So I just add those up, and I have 12 17ths. Now 17 is a prime number, so I can't simplify this anymore, and I know I'm done. The fractions of students working at water tables is 12 17ths. That was a ton of work, and I know that it was probably a little hard to follow along, but you can go through this video as many times as you need and just ask yourself, what is your question asking? What information do you have? And then how am I going to solve this problem? So you always have to make sure you're simplifying. You have to make sure you're answering the question itself. And yeah, that's about it. So I have one more problem, problem 20. Problem 20 asks, the high temperature on Thursday it was -3 degrees Celsius, and the high on Friday was -5 degrees Celsius. So that's our important information right now. So question A just asks, write a number sentence comparing the temperatures using less than or greater than. So less than or greater than. So this is less, greater. And if you don't remember, a number sentence is just something like 1 + 1 = 2. That's a number sentence. So we have to write a number sentence comparing the temperatures. So our temperature of -3 degrees and our temperature of -5 degrees. So all we have to do is use either less or greater to describe our relationship. So there's a few ways to think about this. First, you can remember how far away are we from 0 from each of these. -3 is 3 degrees away from 0, -5 is 5 degrees away from 0, so -5 is further from 0 towards the negative end, so it's actually colder. I'm going to actually draw a number line to help you remember. So here's 0, -1, -2, -3, -4, and -5. So any number that is to the left, just like 0 is to the left of 1, right? 0 is less than 1. We know that, of course. So any number that's to the left is going to be less. -5 is to the left of -3, so -3 is greater than -5. Part B asks us to describe the location of both integers in relationship to each other on a number line. Well, we already made a number line, right? -3, -5. So we can say -5 is to the left of -3 on a number line. Now, if you have any questions, feel free to leave them in the comments of this video, and I'm happy to answer any of them either in class, or I might start doing these videos more often and answer them in the comments or in a follow-up video if everyone's confused. I hope that this was helpful, and I hope that you can get through those corrections and learn a little something today. Thanks, everybody.